Hey guys, today we will be participating in this weekly contest 262. So here I'll just begin and okay, so we have 1 hour 21 minutes left, right? So let us just begin. Uh, what's given like given three integers nums1, nums2 and nums3, return a distinct array containing all the values that are present in at least two out of the three given arrays. Okay, given three integer nums1, nums2 and nums3, return a distinct array containing all the values that are present in at least two out of the three arrays. Okay. For example, it is 1, 1, 3, 2, this is 2, 3, this is 3. The values that are present in at least two arrays are okay, 3, and all threes are and 2. Okay. This nums1, nums2 on 100 and each number is also 100. Okay. So we can just do one thing. We can have some mapping of int comma int, click mapping of exit 4. You can say just 3. So what I do just for each element in nums1, like mapping of 0, we will implement by 1. For to each to nums2, mapping of 0 of 8, not this should be 1. So for auto each to nums3, mapping of 2 divided by 1, mapping of int comma int, for it count, right? So like what we do after that is that uh, for auto each to nums1, it's better to put them all in a set. St of 3 for auto each to nums1, st of 0 for auto each to nums2, st of 1 dot insert e, and then for auto each to nums3, st of 2 dot insert e. I put everything on set, and then I declare a mapping of int for it empty, and again for auto each to st of 0, like mapping of e will be implemented by 1, for auto each to set 1, mapping of e will be implemented by 1, for auto each to st of 2, mapping of e will be implemented by 1, and then we can have some vector vector of the answer for auto each to mapping if e dot second is greater than 2 equal to answer dot goes back e dot first return answer finished your answer 23123 23123 let's try to submit this accepted. To the next question, you are given a 2D grid. You are given a 2D grid integer of size m cross n and an integer x. In one operation, you can add x to or subtract x from any element in the grid. A uni-value grid is a grid where all elements of it are equal. Return the minimum number of operations to make the grid uni-value. Okay, is it recording? Yeah, it's recording. So you are given a 2D grid size m cross n and an integer x. Okay, in one operation, you can add x to or subtract x from any element in the grid. A uni-value grid. Okay. Example, in this case, x is equal to 2. You can add x to or subtract. Okay, x is also given. Subtract x from 8 twice. You can add minimum number of operations to let us first find what are the bounds, rows and columns. So that will be great dot size. M is equal to great of 0 dot size. Let's have some answer as very large value. At the end we will be just returning this answer. Okay, we can univalue do all the elements are equal, returning equations to make it equal. Okay, so let's make use of some drawings. Okay, I think it got stuck for a while. Uh, let's move to paint. So like if we have some grid like this, right, and this is 2, 3, 4 and 5, and let's say x is equal to 2, then if we just convert this grid to some univalue, some value like let's say y and y, then there can be at most two ways. Okay, so if we just replace this one with this one, then we say that let's say it is y, then either we just add some multiple of x or subtract some multiple of y, which means that if it is 2 and if I make it to y, then the difference is like y minus 2, and so it's like the absolute value of this thing uh, needs to be divisible by this x. Okay, So I need to know what value of y should I choose, so that like absolute value of this much uh, divided by x, and then their summation should be minimum. Okay, so if I just make all of this to be y, so if I just make all of these to be y, and then if I just find what is the difference, that will be y minus a of I, and just take their absolute value and divide it by some number x which is given, and then just take their summation. Then it's like I need to minimize this, right? Okay, it's like I need to minimize this quantity. Okay. What should I do? I need to minimize this quantity. And we also know that this quantity needs to be divisible by x, so it's like y modulo x should be equal to a of I modulo x, right? Like it turns out that all the AI values should have the same modulo x. uh, for example, over here if you see, uh, all the uh, all the values have 2, yes, and minus 1. Okay. So the first thing is to check whether all the AI values have the same modulo x or not, right? So so we keep a boolean value or you can say boolean first is equal to minus 1. So now what I do is, like, for I just iterate through my grid. I check if first is equal to minus 1. Just set my first to like uh, grid of ij modulo x. Else I check like if first is not equal to grid of ij modulo x, then simply return minus 1, right? This is the first thing to do. Like, and once we just establish this fact that all the AI values have same modulo x, we can just say that okay, uh, now we need to choose some y value, right? So now what I can say, whatever is this AI modulo x, I can just subtract this value from each value of the grid, and then just say that this y, yes, so I can just subtract this value from each value, and then it condition will be like, then it will be perfect divisible, so it will be y minus x by ai by x modulo. Now this can be computed. Let's call this b of I. So it simply becomes a problem to minimize summation of, let's say, y by x is to be another variable, let's say k minus some b of I, and this is a very famous problem which can be solved easily, right? Okay, so what I need to do is now just go through each element, right? And j is lesser than m, j will be limited by 1. What I do is like, first of all, grid of ij minus is equal to that first element, and then this grid of ij will be divided by x, right? And after doing this, we just keep a vector with ourselves, call it vector of v, and then for auto each to v, you can just iterate through this. We can just push this thing over here, right? Grid of ij, and then we can just sort this. We can have something like int answer to it, and then we can just know that what will be that value, mid value. So that mid value will be equal to basically whatever is the size, uh, size by 2, I guess, right? Size by 2, so it will be equal to v of size by 2, right? And v of size by 2, and then we can just go through each element in this vector and just simply add answer plus is equal to absolute value of basically e minus whatever is the mid, just return it. -1 -1, oh no, this was not what I wanted. Okay, for the first case 2468, so first is equal, okay, it should be int basically 4. I use Stanford test cases. It's 4 5 minus 1, is it so? Yeah, 4 5 minus 1. So basically what I have done, int nm int answer max, first finding the first, if first is not equal to this much, let's do this. Yeah, if first is not equal to this much, return -1, otherwise distract, push everything over here, sort the things, find the mid, and just simply do separate, right? This I think how is total accepted? Yeah, lot many accepted got this. You are given a stream of records about a particular stock. Each record contains a timestamp and the corresponding price of the stock at that time. Each record has a timestamp and the corresponding price of the stock at that time. Okay. Unfortunately, due to volatile nature of stock market, the records do not come in order. Even worse, some records may be incorrect. Another record with same timestamp may appear later in the stream, correcting the price of the previous wrong record. Design an algorithm, okay, that updates the price of a stock at a particular timestamp, correcting the price from any previous record at that timestamp. Find the latest price of the stock based on the current record. The latest price is the price at the latest timestamp recorded. Finds the maximum price that has been based on current record and the minimum price based on the okay. Stock price void update the price of the stock at the given timestamp. Current return the latest price of the stock. Return the maximum price of the stock. Returns the minimum price of the stock. For example, update 1, the timestamp at 1 with corresponding price 10. Update 2, 5 timestamps are 1, 2 with corresponding price 2, 5, right? Current returns 5 because the latest timestamp is 2 with corresponding price 5. Maximum returns 10 times maximum. Update 1 to 3, the timestamp is 1 is 3 5. Stock price dot minimum returns 5, the maximum price is 5 after correction. Oh, okay, timestamp. Okay, so we want to update. So for updating it is quite easy. We can just have mapping of some int comma int, call it mapping, So we can just do mapping of whatever is the timestamp, timestamp, map it to price, whatever is the current price, right? And for current we can just maintain a set of int called st, and we can just insert the timestamp, right? And so first we can find what is the current time, and that will be equal to the maximum in my set, and then we can just simply return whatever is that price. Yeah. And for maximum uh, we can make a set of values, right? So that whenever we do this, so whenever we update the things, first we need to delete it, that. So first of all we just check like if it is already present in my set, uh, or you can say like if it has been mapped to some value, right? If it has been mapped to some value, then actually it should be multi-set, maybe. Yeah, it should be a multi-set of values, right? Multi-set of values. If it is present, then first we just erase it. Erase uh, mapping of whatever is the timestamp. After doing this, we just insert whatever is the price. So you see, uh, I set and multi-set. So for updating, I first check if it is already present in my map. If it is present in my map, I just erase it. Otherwise, then I just map it. Then I insert in the set, and I also insert it in the price, value price. So for maximum, we just simply return uh, asterisk of, let's say, ms dot r begin, and for this I just simply return uh, asterisk of ms dot begin. So this will actually it should not be uh, the name of variable is actually val for me. So we'll just the beginning, maximum, current is current time, maximum time, and then return this mapping of that current time. Otherwise update it, and we just do nothing, right? So stock price we can just simply erase uh, just clear it, we can just clear it, we can just clear it, right? Stack clear value. So let's just run it. Runs a null 510, null 510, null 5, null 2 is submitted, accepted, fine. And this is the last problem. Time is how much? I think okay, it just passed. You are given an integer array nums of 2 into n integers. You need to partition nums into two arrays of length, and to minimize the absolute difference of the sums of the two partition, put each element in one of the subrows. So, for example, uh, this is some kind of nums, like 3973. So, what is you are going to arrays? You need to partition nums into two arrays of length n to minimize the absolute difference of the sum of the arrays. To partition, put each element into one of these subarrays. Okay. So basically, we can take any subset of these 3971, put it in array 1, and put the remaining one in array 2, and we need to minimize the absolute difference between their sums. This is 36 minus 36, right? And I need to divide it exactly two halves, right? It is given that it is only 15. So I don't think it's so hard, like it's very easy, like we just need to find the sum of the subsets, right? So for answer, let's say it is very high value sum int max, and let's say at the end we just return the answer, right? But like let's say what is the value of 2 to the power 15, because I need to iterate over those values. It's fairly simple, right? So we can just iterate over each mask, or int mask is equal to, no, for every mask which contains exactly n by 2, nums dot length is 2 times n. Okay. So for int mask is equal to 1, mask is lesser than 1, 1 left shifted by n. First check like if underscore built-in pop count of mask, and if that is divisible by 2, or you can say if that is divisible by 2, and like that is also, okay, and like that should also be equal to basically n by 2. This is also that it should be divisible by 2, it should be even, and it should be divisible by 2. If it's so, then we can say what is the sum of submask. Sum of submask. So for that we just go from position 0 to position n. Position will be counted by 1, and then I check like if that bit is on or not. If that is on, then just simply add that value to our uh, we just simply add it to our sum. And one thing we do, we have something like total sum to each two nums, right? Total plus is equal to e, right? And so my answer will be like minimum of answer comma absolute value whatever is the sum minus, we know that total minus sum, okay. And we just at the end we just print it. So what I do, like int n is nums, answer is int max total, find the total, iterate over all mask, take that if the mask contains exactly n by 2 bits on, and if it is so we declare some variable sum, we just go for each position, check if that bit is on, if it is on add that to nums, add it to sum, and then simply as a sum of total and return that answer. Let's see what it gives. Okay, it gives some very huge value for these cases. So this gives an unexpected value over 36. Why? Let's give only this one. T6 mask is like by n. Let us first print out what sum they are putting actually. And what is the sum there? Because answer is int max. actually seems like it is not just even entering this. It is 2. That since bits is equal to, I think I must be doing some silly mistake. 112. Let's remove this condition. If bits simply is bits is equal to n by 2, right? Yeah, it's now fine. We can just note this condition, simply run it. 272.0. Minimum possible absolute difference. But will it overflow sometimes? Oh no, you see, nums dot length is 2 times, it may be 30. Yeah, I guess that it is only 50. It is not so. So I think it's probably something like meet in the middle. And I think it's something like meet in the middle. Like we have some array, like it's like 2 times n. Basically, what we can do is like we can just divide this into 2 parts, and both of length n, right? And we can just calculate the sum over every possible 2 to the power n's mask over here, and similarly we'll calculate all the sums over all the 2 to the power n mask over here, and then uh, for every sub mask sum over here. Okay, 1 minute. What we want is like we want to minimize 2 times, not even 2 times. We if we take the sum to be sum, then we want to minimize sum minus total minus sum, which is actually 2 times sum, 2 times sum minus total. So we actually want to know what is the to minimize it, we want to know what is the minimum value which is just greater than uh, you can say just greater than this sum by 2, total by 2, basically total by 2, and what is the minimum maximum value which is just lesser than or equal to this one. Something like this I want. Oof. uh, Sum minus total minus sum 2 times sum minus total, and this is absolute, taking the absolute difference of that, and we want to minimize this thing. Okay. What we can think of now is that Like obviously, uh, if the two subsets which I divide have the sum x and y, then I know that x plus y is basically total, right? Then obviously one of them must be lesser than or equal to n by 2, right? So minimum of x comma y must be lesser than or equal to total by 2. So what we can do is we can just iterate over this minimum, right? So what we can do, we can just choose every possible subsets of this half, and if it is greater than this thing, we just simply ignore. If it is exactly equal to total by 2, we can just simply return 0. Otherwise uh, we just try to make it as large as possible by adding any subset sum from here. Yeah, yeah, that is the logic. Okay, so we don't need to do this. Rather, what we will do now is that we will just divide it into two halves. So we'll have some vector of call it left half, and we will have something called right half. So for int I is equal to 0, I is lesser than n by 2, I will push everything in my left half, and for the rest I will just uh, put in my right half. And then I will just call it sum1, call it get sum of left half, right? And similarly we will be having something uh, get sum of let's say right half. And after getting these two things, what I do is just uh, you can just simply sort these two things, right? Now it don't matter if you sort, if actually it's important to sort it, so we just sort it. Similarly sort the, actually what we are doing is just standard meet in the middle thing. So after sorting it, I just go through each element in my sum1 and check if it is equal to uh, total by 2, or alternatively you can say if 2 times this is equal to total, uh, I just simply return 0. Otherwise if 2 times is greater than total, then just continue. Otherwise what I want is like e plus, or you can just simply say what is the limit that will be equal to total by 2, and what you want is like e plus what is lesser than or equal to limit. So this becomes what is lesser than or equal to limit minus e. So what I do is like auto iterator, first find the upper bound, right? Upper bound sum2 dot begin to sum2 dot n, and like if this is equal to sum1 sum2 dot begin, like if it is not equal to, basically if it is not equal to sum2 dot begin, then uh we just simply do one thing, like move it one back, and what is your current value, that will be e. So just simply add this thing to it, right? And just simply say our answer is equal to minimum of answer comma, like absolute value sum minus, you can say current minus total minus current, and that's it. and we need to implement this function getSum. So this will basically return a vector, call it getSum, and will accept a vector argument as well. And first find what is the size of this vector, size, and then for every mask, that should basically be, yeah, that may be 0 even also. Mask is equal to 0, mask is lesser than 1 limited by n, and mask is limited by 1, and then for n is 0, and just simply check like if mask has that bit on, then just add it to this, right? And we just over here declare some result, or you can say some sum, right? And then simply push this in your answer, is sum, return this answer, and call it vector of answer. So what I'm doing is that we have some vector of int answer iterating over every mask. If that mask has that bit on, sum plus is equal to v of post answer dot push back sum, return this answer. Left right getSum sort 2 times e is equal to total, 2 times e is equal to total, and return 0, or we can just even remove this, nothing to worry. 2 times is greater than total, limit is equal to total by 2, upper bound sum total is, okay, I need to pass this thing also, which is limit minus e, limit minus e, and limit minus e, right? Or you can just simply say that you can simply say like if limit minus e is lesser than 0, then continue. So if limit minus e is lesser than continue, otherwise find this thing, and then just current is e if iterator not some minus minus iterator plus some dot begin. Let's use this. If it's giving very wrong values, especially for this one. Actually total will be equal to 0, total by 2 will be 0, right? Whatever, we just remove this, still 0, and then y is giving me 0, current minus total minus cur, so it actually total is 0, so it 2 times current, so you cannot make this one just 0, right? You cannot make it 0. You cannot, it's not allowed that you just don't take anything from this, and it's allowed to make anything to be
to be, it's maybe possible that you don't take anything from this. It's not allowed. Or you check whether you are taking any empty or not. Like there are three possibilities: either I take everything from this half, either I take everything from this half, or I take some element from both of these two halves. Yes. So we just make one thing, we just simply make it one, and after making this one we just do things. So this is a cross connection, and we can also do one thing, like if we take everything from that element only, so we will be answer is equal to minimum of answer from absolute value of, let's say, e minus total minus e. And we can just also copy this and make it true. Let's run it now. It's still 0. I think it's happening because of this. uh, Limit minus e. What happens if I just simply do this? I think I'm wasting so much of time, but this is okay. But what's the issue with this? Limit is total by 2. Total by 2 will be 0. 0 minus e, which is, in case that is no outer upper bound, sum 2 dot begins limit, so it will be 36. Yeah, I am taking minus 36, right? Minus 36 plus what is equal to basically that much. 36. I am getting 36. Uh, Actually, all the numbers are from minus 10 to the power 7. So if I just simply add 10 to the power 7 to all of them, like if I just simply add 36 to all of them, will it affect? Oh no, actually I need to do one more. 1, 2, okay. mask is also important, right? So it should actually be pair, right? It should actually be pair of things, right? Pair of int comma and. So we push make pair of built-in mob count of mask comma that's some mask comma some. Uh, sort of push like mask comma some. We simply make it vector of pair of int comma int. So this would also be converted to pair of int comma. And now we have something called as vector of int comma. Let's call it vv of n plus 1. I just simply go through each element in my sum 2, and then I do vv of e dot first dot push back e dot second, and then for int I is equal to 1, I is equal to 0, I is lesser than equal to 1, I will be limited by 1. Sort vv of I dot begin to vv of I dot end. So now I just go through each of my sum. I just go through each of my sum. Equal what is the mask count? Mask count will be equal to e dot first. What is the remaining count? Remaining count is e dot n minus mask count. So I need to investigate this remaining count, right? And what is the sum? What is the sum? That will be e dot second. If this sum is basically greater than total by 2, then just continue. Otherwise we have something required is total by 2 minus sum. I want to search over this. So uh, yeah, auto iterator is equal to upper bound vv of that remaining count dot begin to vv of remaining count dot end, and then whatever is required. If iterator is not equal to vv of remaining count dot begin, then we just simply subtract, and then sum plus is equal to asterisk of iterator. Answer is equal to minimum answer from absolute value of sum minus total minus sum, and then simply return this answer. So what we do, we have just this answer int max total में add किया मैंने vector left push back right push back, get this pair vector of v of int vv of n plus 1, and then for each element which is present in sum 2 I am pushing the mask count vv dot push back, what is the count of the mask, and for that corresponding vector I am just pushing that sum element, the sum e dot second, then just sorting everything, and then mask count, then what is the remaining count, what is the sum now, what is the sum I want, iterator is this much, vv of remaining count dot and not equal vv of remaining count dot begin, then minus minus iterator, then sum plus is equal to space program, sum minus total minus sum. Compile error, return answer. Uh, Now we will return a vector of pair of which line 14. Okay, so this should be pair of int comma int. Again compile error, finished 0. See out mask count and what is the sum and what is the remaining count. 1 minus 36. Remaining count is 1. Why? Okay, remaining count should actually be n by 2 minus 1. 22 if not equal to db of I dot empty, अगर ये empty नहीं है तब मुझे ये करना है. Still this is getting very large number 214 something, I don't know why. Actually it is not even coming in this, it's not even entering this. What if I just remove this? Your answer is 0. I think this 0 was also required. What is the condition? But sum is greater than total by 2. But will it work? I think it should work. Actually, I am putting mask is 0, right? But it should actually be starting from 0. And then I think like getting just make this like this and start it from 0. Yes. already very less time. Come on, man. Still, it's not showing the right result. I think the first thing I need to do is this. Then I should run the code. 0 0 so no. It's important to make this mask this one, right? This was expected also. I think like this condition is necessary, certainly, but obviously I don't know why this is just getting. I try to run this some very huge value. Now let me first of all print what is my actually uh, total total and what are the sum there we are just having. Minus 6 is the sum here. Like 9 minus 2, 11, 11 minus 7 is minus 7 minus 1, yes, minus 6, so it's minus 3. Minus 3 I am having. I'm putting the condition that if sum is greater than total by 2, or we can do one more thing, like if sum is greater than 2 by total by 2, I will like to make it equal to that, right? So I will have something, try to do something like this, right? Like sum minus what, so that it is still greater than total by 2, or in fact even equal to also sum what should be greater than or equal to total by 2. So this rules out that like sum, like what should be lesser than or equal to sum minus total by 2, total by 2. So we just gonna we just find what is required total, but here we just reverse it and just simply find the upper bound of this required, and sum, actually we subtract from this and we just continue over here, right? 0, right? So it give me 0. So now sum different total, and what I need to add some 0 also over here, I guess. 0. Now let us, oh my god, it's 0 only. So I guess I need to find a one. 272 0. What about this one? 9. Sub is greater than. It's 2 minus 1, 1, 0 is smaller than or greater than 3. I think we can always add an offset to them without hampering this result. It's always better to add that. Yeah. Each two nums, basically total plus is equal to 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Total may add, I will be adding. And just declare it long. Or in fact, there is one more way. Uh, we can just declare some long n, or like it has become 2 into 10 to the power 7 into 30. 2 into 10 to the power 7 into 38. I will be just be holding. Uh, so basically, just simply add this offset, then total plus is equal to, and not even total, total plus is equal to e, right? And then just keep on doing all these things. Yeah, actually the main thing is doing that only. So now sample test case is run. Yes, fine. Copy. Let's run it now. 9 also, right? I think let's make it 0 over here. What if we make it 0? No. For sample test cases. Okay, I attempted to submit very soon. submit it, accepted. Okay, so finally it got accepted and only 10 minutes left. Okay, let's see the rank. I think like I don't know how many people just solved it. Let's see the recording. Yeah, okay, around 156. Like quite a good solve. Uh, uh, Not a very good rank. 529 with one bug. Okay, but I like this problem: partition array into two arrays to minimize the sum. So let me explain what I am doing over here. So first of all, like we are given some array like this, right? And the length of this can be at most 30, like since n is like of the order of 15, so 2 times n, which will be 30. So the length of this array will be of the order 30. So first of all, what I am doing, I am first normalizing it. What I mean by normalizing is that I am making each of my AIs to hold this property, that AI must be greater than or equal to 0. So for this, what I am doing, I am just adding some value like 10 to the power 7 to each of my array elements, right? So after normalizing this array, obviously each of my AI will be greater than or equal to 0. So a brute force way would have been to just iterate over every possible submask, right? So a brute force, let me increase it. Uh, okay, it just got hanged, right? And but anyway, this was a good question, right? Return the minimum possible absolute difference, right? Uh, it's not responding. Okay, so again, it's not responding. Why? So let me use this one, right? Uh, so as I said, like we are given some array, right? Uh, let's say we are given some array. Let's delete it. Okay, so like so we are given some array like a0, then a1, then a2, then a3, and so on and so up to, let's say, up to n, right? So or you can say a of n minus 1 as well, right? So like what I'm doing is like first of all I'm normalizing it by adding some offset like 10 to the power 7 to each of my these AI values. So after normalizing it, like each of my AI will be hold this property, and if we were to apply some common brute force, so a brute force way would have been to just uh, iterate sorry iterate over each submask and find the sum and just minimize the answer, and just minimize the answer. How? By using this, like answer is equal to minimum of whatever is that sum of my submask minus total minus sum, right? Because if this is the sum of my mask, then the sum of the remaining mask will be the total sum minus the sum this submask. But the time complexity would then be 2 to the power 2n, right? At most, like it will be something like that much. Actually it will be 2 to the power 2n into 2n, but if we just use smart recursion, it can be just brought down to this 2 to the power 2n, but still it's like order of 4 to the power n, which for our case is 15, which will just give you TLE. So we cannot just use this thing. So instead, what we will do, we will use something known as like uh, meet in the middle, right? And this is a very common, you can say, concept used in competitive programming. What happens in this is that we just divide our array into two halves, each of length n by 2. Actually, in our case, our array is of length 2n, so we divide it into two halves, so each will be of length n, and then we just calculate the sum over all the submask of this array and this right array. Like, we just calculate the sum for every possible submask in this array and every possible submask in this array as well, right? And then we just iterate over each submask which we found in this left half, calculate what is the sum. So uh, let's say we have the sum as 10 corresponding to some mask which has, let's say, one bit on, right? Which has one bit on. Then we know that if it has one bit on, I need to add some submask from this right half which has n minus 1 bits on. And we also use one another fact that uh, let's say the submask, if one of the submask has some x and the remaining submask has some y, then it has to be equal to total, right? Then we know that minimum of x comma y will be actually lesser than or equal to total by 2. So I am just iterating over the minimum of them, so it's guaranteed that it should be guaranteed that that the submask I am choosing must have this sum lesser than or equal to total by 2. And probably this is what I am doing here, that if my sum is greater than total by 2, I am just continuing, right? I am just continuing. And otherwise what I am trying to do is like uh, I'm just trying to, I know that okay, my sum of the given submask is over here, and this is total lesser than total by 2, so I'm just trying to make it as nearer to total by 2 as possible, not exceeding total by 2, but just trying to make it as nearer to total by 2 as possible. So for this, uh, I am just trying to find what is the difference between this sum and total by 2, and whatever is this difference, I am just trying to find which is the element, largest element, which is just smaller than this difference. So for this I am using this upper bound, and you see this remainder count. Basically it's uh, as I say, like, we want the submasks to be consisting of n bits. So if the submask which I am iterating over has one bit on, then obviously from the right half I need a submask with n minus 1 bits on. So basically I am just storing for every bit count what are the elements and what are the sums which can be obtained from the right half. So, and then I'm just sorting those things and finding this maximum difference. As I said, you, like, this is total by 2, this is sum. So what is this difference? I'm just trying to find what is the minimum, sorry, what is the maximum element which can be obtained from the right half, consist of this remaining count of bits, count of remaining bits, remaining count, and like have its value lesser than or equal to this difference as well. So just finding that thing, and after finding that thing I am just adding this thing, to make this sum as closer to total by 2 as possible, and then just doing this. Answer is minimum of answer from absolute value sum minus total. So this is what was there. Yeah, it's now like 201, and so yeah, I don't think it will be just going up anyway. So yeah, it was a good contest, like especially this one. So thank you for watching. If you like my channel, please hit the subscribe button. Thank you.